make sure that you understand what the basics were. Otherwise هنكمل عندك ضعف في كل البودكاست ان شاء الله. طيب. بسم الله والصلاة والسلام على رسول الله. So last time we were discussing the idea of transformation of random values. So basically we said that okay, now if you have a voltage and you have to figure a problem. Yes. Yes, that's it. بس شكرا. طيب. Yeah, we were talking about the function of random value. We'll give several examples about when you have a random value of a value and you anticipate processing that value, multiple to power current linear transformation. And we started with the very simple monotonic function, either increasing or decreasing, and we after that we combined the two cases, and we ended up with the general rule that basically fy of y, which is the PDF of y, will be equal to the PDF of x multiplied by the derivative of the inverse of the function, which is t inverse, or divided by the function, which is t of x derivative. Absolute value, because just to take care of whether it's increasing or decreasing. And we came up with several examples, and we were able to solve them. Today we'll start with the non-monotonic. Now we said that we have three cases that we'll discuss in this section. Monotonic, and then non-monotonic, when the function basically goes up and down in a non-organized way. And the third one, we have the discrete value variable, and we do the transformation. So we'll do today the non-monotonic and the discrete value variable. طيب, the non-monotonic, from the name, it's basically a function that goes up and then probably down and then up. So basically it doesn't follow an increasing direction or decreasing direction. So basically it can increase and decrease, like a cosine wave, like a square wave, a square law function, and that. Okay, so in this case, when you have t of x, sorry, y equal t of x, and t of x is a general function that is non-monotonic. In this case, the PDF of y will be the PDF of x. However, we need to sum over the zeros, all zeros of t of x, y equal to x. Okay, so x of n, xn here is the nth zero. So basically, for example, y equal x squared. How many zeros does it have? Right? Plus or minus square root of y. So basically, in this case, this summation will have two values, or two basically terms that we need to add. It will be fx of that zero, the first zero, divided by the derivative of the function evaluated at this zero. You will do it for the first zero, you will have one term, you will add for the next zero, the second zero. So in this case here, y equal x squared, you have two terms here. So the PDF of y will be composed of two terms in this summation. بينما cosine wave, y equal cosine omega 0 t is for the x. How many zeros you have? You have basically summation that basically goes from minus infinity to infinity, because the cosine wave keeps oscillating. So basically for a specific y, you have many x's. This one, this one, this one. Basically for the same y, you have many zeros. And because of that, you end up with infinite summation. We have an example. However, is the idea clear? Any question? Let's solve one example. It will be more. Right. We'll have the cosine, sorry, the x squared. So y equal c multiplied by x squared. C is a constant. It's a constant. So in this case, you will see that the function looks like this. So this is y, and this is x, and it goes like this, down and then up. So it's clearly non-monotonic. Goes down in this part of the x and then goes up in this part, in the positive part of x. And for the specific y0, you have 2x minus x0 and x0. All two zeros. Okay. Now, if you solve for y equals cx squared, the first zero we get, basically just solve for x. What do you get? X squared equals m. Y over c. So if you take the square root, it will be plus minus, right? Y over the square root of y over c. So these are the two zeros. So in this case, fy will be fx evaluated at the first zero multiplied by derivative of the inverse function, which is dy over c dy, absolute value, plus fx evaluated at the second zero multiplied by the derivative of this, the second zero. Or you can think about it as the PDF evaluated at the first zero plus the PDF evaluated at the second zero divided by ايش هذه؟ هذه عبارة عن dy dx evaluated at x equals x1 or 2. Basically, here you x1, here x2. Okay, either way. خلينا بس نحل هذه. What is dy dx? Y is c x squared. So what is dy dx? 2c x, right? Now, the first zero in the first summation, so basically fy of y will be equal to fx over the first zero, right? Y over c divided by the derivative here, the absolute value of 2cx, right? 2c 2c, but what is x? Equal to this, right? Right. So it's 2c multiplied by square root of y over plus fx of x2, which is minus square root of y over c, divided by the PDF of, sorry, the derivative, however, evaluated at the second zero, which is minus 2, right? However, we take the absolute value, right? When you take the absolute value, so it's minus 2c multiplied by square root of y over c, right? However, we take all the absolute value, so basically. So now, if you take the absolute value, what do you have here? C enters inside, what do you get? YC, basically the c in the denominator will cancel one of the c's here, so it will be yc. So it will be 2 and the square root of yc. And the same thing here. If you take the absolute value, the negative cancels, and then the same thing, you get 2 and the square root of yc, which is this one. Okay? واضح شباب؟ How did you get it? So the same thing as the monotonic, however, you will repeat it for the different zeros of the transformation equation. Any question? واضح. Yeah. Again, if you want to do this very well, you need to go back to the monotonic case and try to do it. Try to make sure that you understand العلاقة بين fy with fx and what do you put inside instead of x, which is the zero. Now, if you understand the monotonic, the non-monotonic will be distant. You sum all the different zeros. Okay. Then, if you have no question, you can go to the next one, which is the discrete transformation of discrete random. Now, discrete random variable is easier to deal with because discrete random variables takes specific values. So the PDF is not a continuous function. The continuous random variables, the PDF is a continuous function. And in order to do the find the PDF of the output of the transformation, you need to go to what the process that we described. And discrete, it's much easier because the PDF is a summation of deltas, or basically a PDF in the discrete random variable looks like some deltas, right? So this is a typical PDF or PMF of a discrete random variable, like x1, x2, whatever, right? And so on. So basically, it's a summation of. So now, if I do the transformation, if x goes through this transformation and I get y, I will not find the PDF of y will be when x is discrete. Whatever t of x is, what will be y? Discrete, right? So if this is continuous, then basically any discrete random variable will give you a discrete random variable. So a discrete random variable is x is described by the probability that x equals x1, probability x equals x2, right? وهذه هي الفingers ذلك. Is it? So if I know the probabilities of x1, x2, x3, xn, then I know everything about the PDF, right? Of x. So y will be also discrete. So I'm interested in finding the probability that y equals y1, y2, y, right? So in all, now if we have two cases here, monotonic and non-monotonic. Monotonic means, again, you know that monotonic, regardless of decreasing or increasing, for every y, for every xn, there will be one only image in y. Monotonic means what? Means it either increases or decreases. But regardless, for every y, for every x, 1, you will have y1. You will not have basically, so the output y will correspond to only a single x, right? So the probability that y equals yn will be equal to the probability that x equals x. Right? So if this is x1, this is x2, the y1. This is x2, this is y2. Now, and so on. Now, in order to find the probability distribution of y, if I want to find this, so this is t, tx, y equals x. In order to find the probability distribution of y, I use the probability distribution of x. The probability of y1 equals the probability of x1, the probability of y2 equals the probability of x2, the probability of y3 equals the probability of x3. So basically, the probability of xn goes into y, the corresponding function, the corresponding value of y. Let me give you this example. Let me give you this example. A simple example of a hidden tail, right? Okay, so basically we have x equals 0 with the probability of x equals 0 as half and x equal 1. probability of x equal 1. خلينا بس نغير الارقام بس عشان خلينا بس 0 خلينا minus 1. Okay. minus 1 and 1. So this is minus 1 and we have 1. So we have a random variable that takes two values, minus 1 with the probability of 0.5 and 1 with the probability of 1. Right? So a random variable x can take minus 1 and 1. With equal. Now I apply y, which is equal to x squared. Not x squared. Yeah, I'm off y equal 5x. Okay, 5x. So basically, what will be y values? Well, so y here we have either y can take, right? So basically, y here will be. So y here will be either 5 with the probability of y equal 5 times 0.5 and either minus 5 with the probability that y equal minus 5 as 1. Voilà. So consider probability of y equal 5. In order to find it, you need to go to the corresponding event in x. When does y equal 5? When x equal to the minus 5. Yeah, when x was equal to 1. بينما y equal minus 5 when x equal minus 1. So in order to find the probability distribution of y, I need to find the probability of every event in y. To do it, I need to find the corresponding event in x. And find it. So here, it's a very simple example. You end up with the same PDF. However, the PDF حقت x كانت كيف شكلها يا شباب؟ What was the PDF of x? 2 fingers, right? At minus 1 and 1 with 0.5, 0.5, right? بينما y كيف شكلها؟ Is it the same? إيه لكن وين الدلتاز؟ Minus 5 and 5. So basically one delta at minus 5, another one at 5. واضح؟ So although they look the same, لكن it's not the same function. Okay? It's a different function. This PDF clearly at minus 5 and 5, this is at minus 1 and 1, although they have the same quality. So the whole idea is, in order to find the probability of every value of y, I need to go and see what is the corresponding value of x that is connected by it through the function t of x. هذا إذا كان monotonic. Monotonic means it goes in one direction. باختصار, one value for y corresponds to one value of x. بينما when you have non-monotonic, not necessarily. Non-monotonic مثل الإكزامبل اللي قبل شوي. One value of y corresponds to two values of x. Now, if you have a discrete random variable x, more continuous, then the probability of y equal y0 will be equal to 1. What is the corresponding event? When does y equal y0? When x equals كام? Minus x0 or x0. And are they mutually exclusive or بينهم علاقة? x0 and x0 and minus x0. Can they happen at the same time? No, so they are mutually exclusive. So the probability of y0 equals the probability of x equal x0 or x equal minus x0, which is the summation of the probability of x equal minus x0 plus x equal x. Voila. Right. So going back. So in the non-monotonic case, again, non-monotonic means that y changes with respect to x. Basically, for every y, not necessarily have one x, so only 1 to 1. It might be more than 1x. So in this case, given that y equal tx, the probability that y equals a specific y equals the probability of the values of x such that tx equals 1. Okay, so this event is equivalent to this event. The probability of every value of y equals the probability of the collection of x's such that tx equals 1. Let's have an example and see. So here we have an example that says that, okay, y equal tx, which is this. Monotonic or non-monotonic? Non-monotonic, because you have x squared, x cubed. So basically, for every value of y, you will never find one value of x. This has more than 1 0. So and x is given by this. It has a PDF that looks like this. Probability that x equal minus 1 is 0.1. X equals 0 is 0.3, x equal 1 is 0.4, and x equal 2, 0.2. So let's plot the probability PDF, the PDF of x. PDF of x looks like what is one? Deltas, where? At which one? At minus 1, صح? في finger كم طوله? 0.1. And at 12 also 0, 0.3, and what else? 1 with 0.4, and at 2 with what? 0.2. Okay, so this is the PDF of X. So basically, X takes one of 4 different values with this. The largest probable frequent value is 1. The least frequent value is -1. خلاص? Now I enter into Yx into this transformation. Y equal blah blah blah. Now, in order to find the PDF of Y, I need to find the values that Y takes on us. So what are the values that Y takes? How to find it? I just plug here if the value of X. So when X equal -1, what do you have? 2 minus 1 plus minus 10, right? So basically 2 minus 1 is 1. Is 1 minus 1/3, which is 2/3. So basically -1, d of -1 gives me 2/3. Okay? When X equals 0, what do I get? 2 minus 0 plus 0. So basically for 0x, I get Y equal 2. When X equal 1, what do I get? 2 minus 1, which is 1, plus 1/3. So it's 4/3. And when X equal 2, 2 minus 4, which is -2, plus 8/3. No, it's X equal 2, not -2. So 8/3, you get 2/3. Okay? 8/3 minus 2, which is 6/3, with 2/3. So basically now, I know that Y will have a PDF that looks like this. What are the values that Y can take? 2/3, nice one. The value of 1. 2/3. What else? 4/3 and 2. These are the values that Y can take. 3 values. بينما X كم كان عندها؟ 4 values. It's non-monotonic. Non-monotonic means that for every value of Y, you might end up with more than one value of X, more than one zero. Okay? So now, in order to find the PDF of Y, basically, now I found half of the PDF. I know the values. I don't know how is this total probability of Y distributed on the different values. So in order to know how this, you need to find the probability that Y equal 2/3, Y equal 4/3, Y equal 2. How to find it? The probability that Y equal 2/3 equals what, Shiva? When does Y equal 2/3? It's basically X equals -1 or X equal 2, right? Which is equal to the probability. Or means what? Summation, because they cannot happen. X cannot be -2. There's no common factor. They are mutually exclusive. And because of that, this is equal to X equal -1 plus probability that X equal 2. Okay? Which is كم total values? So X equal -1 كم كانت? 0.1 plus 0.2, which is 0.3. Okay? So X equal 2/3 is 0.3. Now, what about the second value? When does Y equal 4/3? What is the corresponding event? When X equal to probability X equal to 1. Because 4/3 happens when X equal 1. And this is equal to, what is the probability that X equal 1? 0.4. And hence we have a 0.4. Similarly, to the probability that Y equal 2 equals to the probability that X equal comes from. When does Y equal 2? When did Y equal 2? When X equal 0. And what is the probability that X was equal to 0? 0.6. Okay. Right? Clear? So it's a very simple finding of the event, the corresponding event, the event that corresponds to what y value is in x. So y equal to that, you go back to x. What was x equal to for y to be equal to 2 over 2? And we find that x was either -1 or 2. We sum their probabilities, we get it. That's it. Right? Any questions now? So,
Should we know if it is magnetic or not from the equation?
yeah, طبعا. يعني monotonic or not from the shape of t of x. For example, linear functions are monotonic. Functions that have x squared, x to the power whatever, they are not monotonic in general. مثلا y equal 1 over x. What do you think? Monotonic or not? Yeah, so for minus infinity, it's monotonic. Like for 0 to infinity, it's monotonic, right? So it depends on the function, it depends on تعريف الفانكشن من أين كان. Okay? So مثلا 1 over x, 1 equal 1 over x. It's not monotonic in general. However, if x is positive, x was positive function. معناها monotonic ولا لا؟ صح؟ For that x, it's monotonic. For another x, it is monotonic. So the function, whether monotonic or not, depending on the period of definition, which depends on x defined from what periods of numbers. Okay? So I found something x is question. I authentically rather not. Give me the average. لا you put the average of x here يعني مثلا 2 minus average of x to the power 2. In order to find the average of y, the average of y will be the average of all this. So it will be 2 minus expected value of x squared plus expected value of x cubed to the power divided by 2. And you need to find expected value of x squared. You need to find expected value of x cubed. Right, sir?
Can the opposite happen? From 1x to 1?
It's not. Right. Functions are not allowed to go like this. If this is x, this is y. There are no functions like this. This is not a يعني ما هي دالة. The data has to be y equals several values for it's okay. But x cannot have several values. Otherwise, this is not a function. By definition of algebra, maybe Windows to have it. طيب. أي سؤال شباب؟ Okay, so basically this concludes chapter 3, sorry. The list is not an optional section. We will not cover it. So far, what we have done is, and I will just summarize, and then I'll summarize the next class. Next class we can go in chapter 4. In chapter 1, what we started with the set theory because set theory is very useful in defining the events and the relationship between events. كده اتكلمنا عن التقاطع and so on and so forth of sets. And then we talked about the probability axis, the official definition of probability, how to define a probability, and what is an event. An event is a subset of some sets, and then we use whatever we learned in subsets in sets to apply it in each exclusive, independent, and so on. And then we talked about the counting the methods and the combined experiments, and we said that if you have an experiment that is repeated 100 times or 1,000 times, you cannot just keep putting things. You have to be able to count in a very fast way. And we covered some of these counting implications. And then we went to chapter 3. Chapter 2 was about defining the rising value. And in order to get away from the sample space and cast everything into numbers, which is how engineers simplify things, we need to define what we call the rising value. It was a mapping from the sample space elements into numbers. And we defined, most of the rising value we were able to talk about or discuss in the video, or this, which is a function that tells you how is this number one total probability distributed among the different variables. And we define community distribution factor, which tells you how the probability grows from 0 at minus infinity up to 1 at infinity as x increases. It's a community. Right? How does this probability accumulate as x increases? And then we define the condition, and charge. Of course, we discussed in the middle, famous random values, famous distribution, like Gaussian, binomial, Poisson, exponential, and so on. And then chapter 3 was about, okay, now we know that the random value, we know how to describe that. However, in many cases, we are interested in some parameters of that. Like the average, the variance, the schemes, the mean square line. These are called moments. And in order to be able to find moments, we define what we call the expectation of the expected value of pivot inside equals the integral of the pivot inside next to the PDF, and we carry on the integration. And we were able to find the expectation, which is the mean, the variance, the mean square value, and the skewness, and we define several things. And of course, we define in general the moments around the origin, which is the expected value x to the power n, whatever n is, and the central moments, which is typical example by the variance, which is x minus the value. Basically compares the random value with the average, and then takes square q to the power 4 or so on. This we call the central moments. And then we said, okay, finding the moments is not a simple thing, because it usually involves integration, higher order integration, x to the power whatever, multiplied by PDF, which might be complicated by itself. And we have seen the simplest PDF that we work with is exponential, one of the simplest, and we ended up with several by far steps to carry on the integration. We said, okay, there are two functions that can help in finding the moments, which were the moment generating function, and which is the Laplace transform of the PDF, and the characteristic function, which was the Fourier transform of the PDF, right? And we found that they are we simplify our life in a much easier way, because we converted finding the moments from integration, which is integration, into differentiating the characteristic function and setting only the position. And then, okay, we said, now if we have a transformation of a random value, voted into power, whatever, we need to find the PDF of the new value that we are interested in. I'm not interested in the I'm interested in the power method. So I need to be able to find the PDF, the distribution of this new value. And we must show the different places we turn and if you have a statement. And this basically concludes chapter 3. Now, in chapter 4, what we'll do next time will be a generalization of chapter 2, where basically we will define two random values at a time. So now we were able to describe, for example, a random value that describes the temperature. Well, in many cases, the weather is not defined by only the temperature. It's defined by temperature, probably, and the humidity, temperature, and pressure. So you have more than one random variable that are varying in a related way. In this case, we will define random variable for temperature, another random variable for example for pressure. And we will define them together, and we will try to find the joint PDA, the joint CDA, and the joint moments, and so on. Okay, all right, chapter 4, and it will be all about this. And we'll define also the relationship between these two random values. Are they related? لما يتغير التمبرتشر هل البريشر يتغير معها سرعة؟ ولا ما معناها بعض؟ X is not has nothing to do with Y. ما معناها واحد يتغير ثاني يتغير بشكل مختلف. So we will define what we call independence, correlation, and then we'll go to chapter 5, where basically we repeat what we did in chapter 3, which is moments for joint random value. So now chapter 4 and chapter 5 will be image of chapter 2 and chapter 3. However, instead of doing it for one random value, we will do for two random values. We didn't have a multiple, but we will focus on two random values. While track had a couple of examples for the next 3 weeks. So if you have a problem with chapter 2 or chapter 3, you will have a problem with chapter 4 and 5. So please make sure that you go over material, make sure that you solve as many problems as you want. If you have any question, I am always available. Send me the attendance, please. I have it. Thank you. And